Hey guys, welcome back to Vedic Math Advantage. Last video, we learned how to find square roots for perfect square numbers under 4 digits or 4 digits or under. Today, we'll be learning how to do square roots for numbers that are greater than 4 digits. Let's begin. So we'll be doing square roots for numbers greater than 4 digits. Okay? So you might find this technique very similar to the flag division technique that I have taught a few videos ago. So similar to that, you start by drawing something like this, and then you write the number to be square rooted. Like in this case, we want to find the root of 64009. Now, in the previous video, the technique would have been to split it up into two halves and using the left half and then the right half and using the unit digit and all that. But this can't be used here because we have more than 4 digits. So in this case, it's 5 digits, could be 6, could be 7, could be 8. So that technique wouldn't work. So what we're going to do here on the top, leaving enough space between the digits, write down each of them like that. And now separate the last 2 digits for remainders or whatever would be left. And I say last 2 digits because here I know that the square root is going to be 3 digits long. Let me tell you how. By mere observation, you can see that the largest 2-digit number, 99, squared would be, what do you think it would be? It would be 9801, which is 4 digits. So this one has to be minimum 5 digits. Am I right? And the smallest 4-digit number, which is 1000, its square is something like this, which is way larger than the number we have here. So all the numbers between these two, okay, will have square roots that are 3 digits. I repeat, square roots that are 3 digits. So I know that here the answer is 3 digits, and for 3 digits you leave behind 2 spots for remainder, but it changes as the number of digits in your square root changes as well. So for example, for 4-digit square roots, you would have to give 3 spots, if I'm not wrong. Okay, let's begin with the answer. What we do first is we split each of them into groups of 2. So 1, there's 2. And you split it from the right. Okay, let me just put this in a different color. We have 1, we have 2. Okay, so these are the groups, and this matters only for the first step, just to see what to take for this. Okay, let me explain. So from the right you take groups of 2 and you make like this. Now the first group is just 6. Now we take the nearest square root to 6, which is less than it. So for example, if we have a number like 20, the nearest square root in this type of situation we would have to take as 4 rather than 5. Whether it was 20, 21, 22, 23 or even for 24, which is just short of 25, we would have to take 4 as the nearest square root. Okay? Because of course you can't exceed, or you can't subtract more than what is there. So back to the question, we have 6, nearest square root closest to 6 would be 2, because 2 squared is 4, which is less than 6. And what you write here, you basically double it. So we have 2 here, so we write the double of 2 here. And so what did we get? 2 squared is 4. So 6 minus 4. We subtract over here. 6 minus 4 would give us a 2. And now we write this 2 over here. So we carry it forward. And we divide by 4. Okay? So we have 2 and we want to divide by 4. How much would that come? That would be 6. Am I right? But remember when I said this was very similar to flag division process? This is because we have a similar subtracting mechanism over here. So once we found our multiplicand 6, so the remainder, 24 minus 4 into 6, which is 24, remainder is nothing. But what is our next step? Our next step is to find the duplex of the digits from the second digit onwards. I hope you understood. So basically we ignore the first digit for this part of the step. Second digit onwards, you start subtracting the duplex in each step. So here the duplex of 6 alone. So remember to exclude the first digit. So 2 is not in the equation here. Duplex of 6, that would be 36. So 0, 0 minus 36 is not going to happen. So what should we do? We should prepare for it in advance by taking a smaller number like 5. And this step might be difficult to foresee as to what number you can take, and even I struggle with it sometimes, but it will get better with practice. So 4 5s are 20, so minus 20, remainder of 4. Now this 4 goes as a carry over here. Okay, and our next step is to subtract the duplex of 5. And finally, we can subtract. The duplex of 5 is that, and 15 is our final answer. So next we go divide 15 by 4. So 15 by 4 would come up to 3. Shall we check if it works? So 3, okay. So we have minus 12. This subtraction part should mainly be done in the head. Okay, that would make it much more neater on paper, but it's up to you. Then we have 30 over here. Subtract the duplex of 5 and 3, right? 5 3s are 15. 15 times 2, 30. So minus 30 we have here. Okay, so 0 goes over here as a carry, and since we cannot divide 0 by 4, so you put a 0 over here. And now subtract the next duplex, including the part of the remainder. So it will go like this. We should find the duplex of 530. The duplex of 530 would be naturally just the duplex of 3, because duplex of 5 and 0 is 0. 5 into 0 is 0, 0 into 2, back to 0. But here 3, so we need to find the duplex of 3. 3 squared is 9, so minus 9, and we have our answer. So the root of 64009 is equal to 253. Let me show you one more example of how this would go. Okay, we have 5, 7, 9, 1, 3, 2. Let me just space it out once because it should be neater. 5, 7, 9, 1, 3, 2. Okay, so we know this is a 6-digit number, and of course, as I showed last time, 1000 squared is like 7 digits. So this one square root is still a 3-digit number, which means we have to separate only the last 2 digits. We start the grouping. So from the left 2, again 2, and so our first group has 57. And only for the first step we take this as a group. Okay, now nearest square root to 57, that would be 7 squared, which is 49. Okay, 7 2s are 14, so we'll put 14 over there. And now the excess, 57 minus 49, that's 8, so 89. Next step here, divide. Okay, 89 divided by 14. Now if we go for a 6, right, 14 5 are 17, 46 are 84, so we can go for a 6. Minus 84, remainder is 5. So this 5 goes over here and we subtract. Don't forget to subtract the duplex of 6 alone. So duplex of 6 is 36. 51 minus 36, that would give us 15. Now we can go for 1 maybe. Okay, so remainder, after subtracting, the difference would be just 1. So 13 is our next digit. Now duplex of 6 and 1 is 12, so minus 12 is 1, and we can't divide, so this goes 0 over there. And then we take this one over here. Okay, and we have duplex of 610, that's just 1, so 12 minus 1 is 11. So our final remainder for this question is 11. This means that if we had subtracted 11 from 579132, then the resulting answer being 579121, our answer, or rather our square root, would be 761. I hope you understood this technique. This technique can actually also be used to go into decimals, but that's a topic for another day. Until then.